We have ignition, and we have liftoff. We have liftoff of the Titan Centaur carrying the first of two Voyager spacecraft to extend man's senses farther into the solar system than ever before.
In 1977, NASA launched Voyager 1 and 2 in a mission to study the outer planets of our solar system, before embarking on an unprecedented journey into interstellar space. They carried a message with them, a golden record designed by a team led by the famous astronomer Carl Sagan. It was meant for anyone who might find it in the vastness of space. But how might aliens decode the golden record if they ever come across Voyager? First of all, when you look at the record's cover, you notice some engravings on it, a set of universal instructions. The first thing they would see is a pulsar map showing the location of the solar system, along with a diagram representing two hydrogen atoms. One has an electron pointing up, while the other has an electron pointing down. This change in spin, known as a hyperfine transition, is a constant phenomenon observed all around the universe. It emits radio waves at 1420.406 MHz, which translates into a period of roughly 7.04 times 10 to the minus 10 seconds. This becomes the fundamental time unit to interpret the rest of the data. Any civilization advanced enough to find Voyager is going to be so familiar with those facts. Next to that are binary numbers represented by zeros and ones. The first represents this number. If multiplied by the time unit, we get 3.6 seconds, the time for one full rotation of the record. The second one is equal to 3,229 seconds when multiplied by the time unit, which represents the total runtime of the record. From just those symbols, they can determine how fast to spin the record. Suppose the decoding is done correctly and the disk takes 3.6 seconds for every rotation, they will hear greetings in 59 human languages.
Hello from the children of planet Earth.
And one whale language. A 12-minute sound essay including a kiss, a baby's cry, and 90 minutes of our greatest songs. The second side contains images encoded as audio. If aliens were to notice that the waveform isn't speech or music, but structured in regular bursts, if we look at this symbol, we can see audio waves and binary numbers. If we convert the binary numbers into decimal, we get this number. Again, if we multiply this by the time unit, we get 8 milliseconds, which means each horizontal line of the image corresponds to 8 milliseconds of the audio. In addition, this symbol shows that 512 audio waves create one image. So to decode the audio into visuals, you would take the waveform, break it into chunks that are exactly 8 milliseconds long, and treat each chunk as one line of an image. By converting waveform amplitudes into grayscale values and stacking 500 of those 8 millisecond slices top to bottom, they construct a complete picture. The first picture is a circle, which is also on the record's cover. It will affirm they are moving on the right direction. The next 115 encoded pictures are on our science, our civilization, our biology, and our planet. If you are curious about the existence of aliens, check out this video about a star that may be surrounded by an alien-built Dyson sphere.